Hey, seventh graders, it's Mrs. Wyland. Sorry I couldn't be here today. I completely forgot that I had a science meeting all day at the district office, so that's where I am. I wanted to walk you through what you're going to be doing today in class. So if you could open your science packets to page 5, you will see exactly what you see up here on the big screen. And I'm going to walk you through this page, thinking that it's really just a review of what we know so far about Wegener's idea of continental drift. So think of this as notes and a review, and I want you to write things in as I go with what's up on the big screen. All right, so we know already that Wegener's hypothesis was that all the continents had once been joined together in a single landmass and have been drifting apart ever since. Wegener called this landmass Pangaea, which means all lands. And the continents are still moving today. They're moving a few inches a year. And we'll talk more throughout this unit about where is each landmass going. And in particular, where is North America going? And what does that mean for the future of our continent? Wegener came up with this idea by utilizing 3 pieces of evidence. And so first piece of evidence, and again, this is not in order of importance, but first piece of evidence was the category of landforms. And please make sure when you take notes that you don't just write the word landforms, that you actually write the little bit of notes underneath about mountain ranges and shape. So Wegener noticed that when he pieced together continents, in particular, when he pieced together South America and Africa, that there were rock types that form when mountains form that seemed to match up. So it looked to him like there were these ancient mountain ranges that were consistent from the 2 different continents. And he thought, well, this can't just be a coincidence. They must match up so nicely because South America and Africa had once been together. He also noticed that the general shape of many of the continents seemed to match up nicely, kind of like a jigsaw puzzle. All right, evidence number 2. He used fossils to help him piece together the continents. There's lots of fossils he used, but the one that we'll probably talk about the most in this class is the Glossopteris plant. And Wegener, in his research, noticed that this plant was found all over the world on many different continents, which he just thought seemed really odd. How could the same life form have evolved on various continents? That's not how evolution works. So he thought, well, perhaps the land masses had all been together. And some people would argue, some of the skeptics would say, well, Wegener, couldn't the seeds from this plant have blown across in the wind from continent to continent, or gone across in the waves in the ocean? And Wegener, after investigation of the seeds, felt like the seed itself was much too heavy to have blown across that type of distance and was too fragile to have been able to handle a trip across the oceans. Evidence category 3 is climate. And this one is the one that tends to confuse kids the most in general because it talks about coal. And what's interesting is Alfred Wegener looked and noticed that there were coal deposits in the ground in places that didn't make a whole lot of sense. There was coal in places like Antarctica, which is really strange if you think about it at first, because coal is actually made from dead plant material. And Antarctica today doesn't have a lot of plants. So how in the world could there be coal in Antarctica? Well, Wegener concluded that Antarctica must have been closer to the equator long ago. Lots of plants existed. The plants died, got buried in the ground. They were squished and compacted as they got deeper into the planet, and over time, and I mean millions of years, turned into coal. And when Antarctica drifted south to the South Pole, it carried the coal along with it. Wegener also noticed that there were scratches from glaciers in Africa, which again is bizarre. Africa is warm today. Glaciers need a cold climate. So Wegener concluded that Africa must have been closer to the South Pole long ago, and then drifted north. So he had all this wonderful evidence, which is great, but he had one major problem. Wegener could not come up with, Wegener could not come up with an idea for how the continents actually moved. It seems completely not even possible. Let's see if I can fix this. I'm sorry, guys. Basically says he just could not come up with an idea of how the continents could move. I don't feel the ground move. You can't see it moving, and yet Wegener knew that it had moved. And so other scientists did not believe him. And sadly, Wegener died before technology was created later in the 1950s for us to be able to answer this very question of how are the continents moving. So hopefully now you've taken your notes on page 5. What I'm now going to do is ask that you watch a video about good old Alfred Wegener. Just going to summarize some of the things I talked about. And then there is a lovely little song that's going to get stuck in your head for you to listen to. All right, I'm going to play for you the video first. Yeah. Okay. Okay. So now I would like to show you this lovely song that you are just going to have in your head all day. Here it is. Okay. Oh, let's see here. All right, so now that you have seen all of that, you listened to a very catchy song. I'm going to end this screencast now and listen to your stuff for further direction. Thank you.